Good morning, this is Miss Cummings. This is Pythagorean theorem models. So the models are down here, and basically the theorem says is if three squares form a right triangle, then the sum of the areas of the two smaller squares is equal to the area of the largest square. If the area of the square is given, then you're going to use the information to label the sides of the square. This unit relates to when you were estimating square roots and finding squares. If the sides of the square is given, then use the information to label the area of the square. Area is annotated with units squared. So that's going to be a big hint that if you don't know what it is, it should have units squared, so you know that that's an area and appears on the inside of each square. Label the sides of each triangle by using the sides of the square. So here on the diagram, this is a side of a square, but it's also the side of a triangle. Draw your right angle in the diagram to help you identify the legs. So the legs are always adjacent or connected to the right angle. And then the legs of a right triangle are adjacent to the right angle. Just said that. The legs are the two shortest sides of the right triangle. That's huge because you can check your work easily. And then identify your hypotenuse. The hypotenuse is always the longest side of the right triangle. So here is a model, and what it's going to ask for is a couple of things. So if you have this and it tells you that it's a Pythagorean model, you know that the three squares form a right triangle because they'll say it's Pythagorean, that's one of them. There's your right angle. And it says the sum of the area of the two smaller squares is equal to the area of the largest. So this one is 36 plus 64, which is 100 centimeters squared. Now, since this is an area of a square, to get out of a square, you do the inverse operation with the square root, which means the square root of 64 is 8. The square root of 36 is 6, and the square root of 100 is 10. The legs are attached to the right angle, so they are 6, 6, and 8. The hypotenuse, it's always the longest side, and between 6, 8, and 10, 10 is the hypotenuse. I'm going to repeat that process on the next model. So if you have 9 centimeters squared and 16 centimeters squared, this is the right angle. If you have the two smaller squares, you add them together, and they give you the area of the larger square. To find the sides of the triangles, which are also the sides of the squares, you take the square root of the area of a square. Square root of 25 is 5. Square root of 16 is 4, and square root of 9 is 3. The legs are 3 and 4, and the hypotenuse is 5. Put a star on this one because this is the most famous right triangle. He's a 3, 4, 5. He's also a cousin to the 3, 4, 5. He is just a 3, 4, 5 times 2. Okay, on the last one, we have the larger square. And so if you have the larger square, to find one of the smaller squares, you can do 169 minus 144, which is 25. So there's a 25 centimeters squared here. Square root of 169 is 13. Square root of 144 is 12. Square root of 25 is 5. The legs are 5 and 12. The hypotenuse is 13. That is Pythagorean models. That's the notes. The next video will be over the practice problems of how to determine, given three squares, if they're going to make a right triangle when you hook them together, and more model problems.